Stanford University.
Okay, well, welcome to Lecture 15 of CS193P for fall of 2013-14. And our primary topic today is going to be the map kit, which is kind of the UI on what we talked about on Monday. As part of that, though, and especially in the demonstration that I do, I'm going to show you two things about segues that are pretty important. One is how to fire off a segue from code. So far, all the time that we've made a segue go, we just dragged from something in a storyboard to another storyboard, and then we clicked on that something, it would segue. So now we're going to be able to fire off a segue from in code. And then I'm also going to teach you a new kind of segue today, which is the embed segue. Now I'm going to demo that as well in a big demo that shows you all the map stuff and the manual segue and the embed segue. Okay, so that's what's on tap for today. And so MapKit. So what is MapKit? MapKit is basically user interface for locations, and its primary class is this UI view called an MK map view. The whole map view stuff is in a different framework called the MapKit framework. When you want to use the MapKit framework, you have to actually explicitly go into your project settings and set it to be linked. Otherwise, all these classes like MK map view won't be there, and I'm going to show that in the demo how you do that. So inside of the map view, you have these little pins. Okay, they look a little red pin there. They can be different colors. These are called annotation views. Okay, so every annotation view in there, and you can customize this. You can subclass annotation view to make it not look like a pin if you want. But these annotation views are responsible for showing some place in the world. And they have a pin, but then they also have this little call out. If you click on them, you see that little white bar right there. And that call out can be customized a little bit. The title that's in it, and it can have a little subtitle, and also it can have left and right accessory views. So this one has a left accessory view, which is an image view, and has a right accessory view, which is a little button that you can click on. So in our demo, we're going to do all of this. Okay, we're going to cover all of these various parts, what's going on. But the main thing to understand is how you create a map view and how you put these things on the map. So map view, just alloc init, or more often we drag it out from the palette in Xcode. And the way we put the pins on there is we add these things called annotations. Okay, so an annotation is really just an ID that responds to this protocol. You see this MK annotation protocol up here. So any object in your entire application that responds to this protocol can just be dropped onto the map view. Okay, so what's in this protocol? Very simple. It's got a couple optional methods, the title and subtitle. So in that little white call out that we saw, that's going to be the title and subtitle there. And then it's got a very important required property, which is the coordinate. So the coordinate is just the latitude and longitude as specified by this CL location coordinate C struct. And so any object that can answer these, really just this one question of the coordinate, but usually we want title and subtitle too, can be thrown on a map. And for example, in the demo that we're going to do, we're going to extend Photomania. I'm just going to throw photo objects in there. In fact, photo objects already implement title and subtitle, so all we really need to do to make a photo object be an MK annotation and respond to that protocol is to implement the required coordinate method, and that's what we're going to do. And then we can just throw photos on the map. We don't have to make any other special classes or anything. We just throw the photos themselves up there. When you're setting the annotations, there's a property on MK map view which is an NS array of annotations. That's all the annotations that the map view is showing. But that's read-only property, so you can't set the array that way. You have to use these add annotation methods or add annotations, and same thing removing them. So you add and remove them with these methods. You don't manipulate that array directly. It's a pretty good idea if you have the information, to add all of your annotations up front to the map view. Adding an annotation is actually pretty low overhead, especially if that annotation is not on screen currently. And that's because those MK annotation views, the little pin that does the call out, those things are reused like a table views rows. Okay? So if you have hundreds of annotations, but only 5 of them are on the screen, you're only going to create 5 of those MK annotation views. And as you kind of move around in the world and they go off screen, they'll get reused for new ones. Okay? So letting the map view know all the annotations up front is nice to help it manage its internal performance or whatever. So it's generally recommended, but you don't always know. Sometimes you don't know all the annotations up front. It's happening in real time or something. So what do annotations look like? They generally look like a pin, but there's a lot of methods that you can call in MK annotation view, and you can also subclass MK annotation view to draw something different in a pin. And this call out is a little more difficult to subclass and make different. So if you can get by with just doing this left and right call out business, then that's good because that's easy. If you want to do more, then it's kind of beyond the scope of this class and you're going to have to do some searching around. It's doable, but doing something different than that basic call out with title, subtitle, left and right accessory view is a little more difficult. The contents of that call out are kind of interesting. When do you set those up? Well, there is a map. Okay, the map view has a delegate we're going to talk about, and one of the map view delegate methods is essentially build this MK annotation view for me, including the left and right accessory views. You know, alloc init those as well. And you can load those up at the time you build it, or you can wait until the pin is pressed to load those up. Now, why would you want to wait till the pin is pressed to load up those annotation views? Well, let's look at this example right here. You got that thumbnail. What if that thumbnail requires a flicker fetch? Okay, well, you don't want to fetch that photo for all the pins in the entire world, or even all the pins that are visible on screen. You only want to load that flicker, do that flicker fetch when a pin is clicked on. So there's this delegate method in the map view called map view did select annotation view. They get called when you click on a pin. That's a good place to do that flicker fetch. Okay, load up the call out. And we're going to do that in the demo, see how that works too. So we have these MK annotation views that are going to show these ID MK annotations. How do those two get connected up? And they get connected up by this map view delegate method called map view view for annotation. And it returns a view for an annotation. This is almost exactly the same as self row and index path in table view. Okay, self-row index path, you give it a section in a row, it gives you back a UI table view cell, which is a view, to display that row. Same thing here. It's going to give you an annotation, and you're going to give it back an MK annotation view to draw that annotation. Okay, now map view even has this mechanism, the DQ reusable thing, like table view has, right? So you can say sender, which is the map view there, DQ reusable annotation view with identifier, you give it an identifier, and if it's got a pin view, an MK annotation view that it got thrown off the screen and it can reuse it, it'll bring it in and give it to you here. Okay? But if it doesn't have any, then in the table view case, what happens? The system will automatically duplicate that prototype, right? You got the prototype cell that we set up in the storyboard, and it'll duplicate it, but that doesn't happen here because we don't get to do that in the map view. The map view doesn't have all this mechanism for prototype cells and everything. So if that comes back as nil, the DQ reusable, then we have to alloc init the MK annotation view ourselves. So here, for example, I'm making an MK pin annotation view, which comes in iOS. It's the thing that can draw a red pin. I think it can do purple and one other color. And I just alloc init it with annotation reuse identifier. Now, the fact that I pass that reuse identifier there when I alloc init it means that if it ever gets thrown out, it will come back in the reuse queue. So that's the thing that ties it to the reuse queue. So that's how the things go back and forth. And then inside there, I might also set up my left and right accessory views, maybe not put the content in there like the image, but I might create the UI image view, right, and set that to be the left one and then set the button to be the right one. Okay? Outside of that, if not a view, okay, so now I have an a view either that I DQ'd or that I made myself. Here's where I load up whatever is cheap to load up, okay, into that MK annotation view, okay? You wouldn't want to do expensive things here. We're going to wait till it's clicked. If it's something that's going to be displayed immediately about the pin, like you're using a different image than the pin, then obviously you need to set that here. You can't wait till it's clicked on to load that up. Okay? So what kind of properties are there on this MK annotation view, the thing you're returning from that method? There's obviously the annotation. There's the left and right callout accessory view. You see those are just UI views that you can set. There's whether it's enableable. There's even whether it's draggable. If the MK pin is draggable, then the annotation has to not only implement that coordinate method, it has to implement the set coordinate method. Okay, because you're going to pick that view up, pin up, and move it. When it drops, the annotation has to be moved, so it has to have a set coordinate method. Okay, otherwise setting draggable here is not going to work. And then the image that you see here, this property, that's the image that replaces the pin. Okay, that's instead of the pin. That's not the image that's in the call out. That's we're going to put in the left accessory call out accessory view. One thing that's kind of cool, if you set one of the accessory views to be a UI control, most notably a UI button, inherits from UI control, then yeah, you can put that button in the call out accessory view and you can set up target action to it and that would all be fine, that would probably work. But since that's so common to do in an MK annotation view, there's a nice map view delegate method here called map view annotation view call out accessory control tapped that will get called if the person taps on it. So if you put a button in that little call out, if someone taps on it, this will get called. And you'll know which annotation view it was tapped on, right? And you won't have to do target action in that button. So we'll do that in the demo as well. So did select annotation view. So this is the thing that gets called in the map view delegate, map view, it's called map view colon did select annotation view when a pin is clicked on. Okay, when someone actually clicks on that red pin. Now it's going to automatically put the call out up as long as you set the property can show call out in the MK annotation view. By the way, if you don't implement that annotation view for annotation delegate method where you build the view, it'll automatically create one for you. It's just going to be a pin. It's going to have no left and right call out accessory, but it will show a call out with the title and the subtitle. Okay, that's what you get if you don't do anything. We'll do that in the demo too. So here in did select annotation view, I clicked on the pin. Here's where I might say, oh, let's do that flicker fetch. You know, at least let's fire it off in another thread here. Okay, we don't even want to waste our time firing it off, and hopefully you're learning this in your homework too. You don't want to really fetch that thumbnail for a row that's not on screen. It's going to waste of time to do that. Same thing here. Until someone clicks on that pin, we probably don't want to fire this flicker fetch off. When the flicker fetch comes back, just like the table view, we're going to have to be careful to make sure that this call out is still associated with this annotation and all that, because these things get reused just like the table view rows get reused. But anyway, so this is where you could load up your call out accessory views. You could also maybe segue here. Okay, this might be a place to segue, but you would have to segue in code here, and because there's no way in Storyboard to like control drag from the pins, they're not on screen until you start adding annotations. So here we could manual segue, and we'll do that in the demo. You can configure the way to map displays. Okay, first of all, the Maps display is just like the Maps app. So I'm not really going to go into all the things you can configure about the map, but pretty much anything you can do in the Maps app, including the 3D and rotating around, and zooming in and out, all of that you can do with the map view. Okay, also including hybrid mode, where it's a satellite image overlaid with roads and all that. That's all doable. So you want to definitely check out the MK Map View API to see all the incredible amount of things you can do. You can show the user's current location. Okay, so it'll go use that core location stuff we talked about in the last lecture, find out where the user currently is using GPS. It'll show that on your map. You can also restrict things about it. Maybe you don't want the user to go into 3D mode, then you can turn the pitch enabled off and they won't be able to pitch. Okay, they pitch by doing kind of a little two-finger gesture there. They won't be able to do that if you turn this off. Same thing with rotate. Maybe you always want north up and you don't want them to be able to rotate around to a different thing. You can do that. So let's talk briefly about the 3D of the maps. And a big issue with this 3D, it's not really 3D, it's kind of 2.5D, right? This is a 2D map, but you know, it has some information there about buildings and their 3D representation. So it kind of, when you pitch up, it can show you a bit of a 3D representation. The main way you're going to interact with that in code is you're going to want to specify where the camera is, okay? Where is the camera that's looking at the streets or whatever that the person looking at the map. And you can specify the camera via a coordinate of where the camera is and which way it's pointing and how much it's pitched and what altitude it's at. But one of the easiest ways